subset of this population is what we refer to as a sample. And a sample, I will denote by small letter s. This can be an empty set. An empty set is a subset of this population, or we could have S to be equal to, possibly I could get a 1 and a 2, or the sample could be anything, a 4, a 5, and a 6, or eventually I could have a sample that is nothing else but the entire population, 1, 2, 3, 4, 5, 6. By set theory, a sample can be an empty set or can actually be the entire space, the entire elements and objects of the actual population and anything in between. The reason why we draw samples is so that we could find statistics. I just want to repeat this point, and then we infer these statistics on the actual parameters of a population. And here we are now, just to highlight in our notes that a parameter is a numerical measure, and this numerical measure is from an actual population. On the other hand, a statistic is a numerical measure that is gotten from the sample data. So a statistic is going to be drawn from the sample, while a parameter is going to be drawn from an actual population. Going further in our lecture notes, we could talk about quantitative and types of data which are quantitative and qualitative. Quantitative simply means dealing with actual numerical measures, while quantitative is non-numerical, meaning these are observations that have to do with maybe color, size, and all sorts kind of non-numerical measures that we might be interested in a particular population or data set. By and large, there are some sampling techniques that we will be interested as we go deeper into this module. But necessary and sufficient for this point is the fact that we want to always make sure we draw what we term as a random sample. A random sampling technique is such that we have picking of elements from an actual population that is unbiased. This is the statistical word. There is no biasness. Imagine the example I gave in class. We want to find the event of interest is that we find the average height, find the mean height of male students at CBU. So the actual population here, let us assume that the population of male students at CBU is, say, 4,000 students, 4,000 male students. And out of these 4,000 male students, the event of finding the average height means for every male student we find at the university, we have to measure their height and add all of them, divide by 4,000. Now imagine how much time, just how tedious and how consuming and how heavy resource, money will be involved for us to do that. It will take us days, it will take us forever. There's just so much involved in measuring the height of every male student.